Hey math enthusiast, I'm here to go over the notes on slopes of parallel and perpendicular lines. So first let's think about how we define slope. So the slope, which we use the letter M to represent slope, of a non-vertical line is the ratio of the vertical change, also known as the rise, compared to the horizontal change, also known as the run. So my basic definition is rise over run. And then let's think about the different types of slopes that we can have. So looking at my graph, I'm going to be going from left to right. So it's going to be a negative slope, then it's going to be falling. So in my graph off to the right, it would be line J that has a negative slope. So it's falling when I go from left to right. Positive slope would be rising, going from left to right. So in this case, it looks like line K would have a positive slope. The next two, zero slope, this line is just horizontal. So it has no rise at all. So that would be like line L down here, or the x-axis that has a zero slope. And the last one, undefined, that is a vertical line. So all vertical lines have an undefined slope, like line N here. So how do I calculate my slope? Well, slope is equal to change in y, which is my rise, over change in x, which is my run. So we said earlier it's defined as rise over run. As far as calculating that, I'm going to be doing y2 minus y1 over x2 minus x1 with any 2 points on my line. So for this first example, I'm looking for the slope of the line that passes through points A, B. So we'll try to sketch out that line. The other thing I'm going to want are these coordinates. So where exactly is A and where exactly is B? The next thing you can do is label your coordinates. So we need an x1, y1, we need an x2, y2. So we'll say this is our x1, y1 up top, and this is our x2, y2. So now all I have to do is plug them into my formula. So it looks like for our y2, we're going to have negative 2 minus y1. x2 is negative 3 minus x1. So it looks like our slope is going to end up being negative 3 over negative 6. So two things are going to happen here. First, both these negatives are going to cancel out. It's going to turn into positive. The other thing is I can reduce 3 over 6 to 1 over 2. So there's my final answer. There's my slope. Now, the other option is, since it's on the graph, what you can do is see how far up and over, or what the rise and run is, from one point to another. So I'm going to start with point B since that's on the left, and I'm going from left to right. Looks like we rise 3 units, and we run 6 units to get to A. So I could use that to jot down my slope. I know it's positive because it's rising as I go from left to right, and then I can reduce it, and I'm going to end up with the same slope. Let's take a look at number 2. So I'm still focused on A and B. Now it looks like this is the line that I'm trying to find the slope for. And my graph is also going by 2's. So first let's figure out what our coordinates is. Now it's only going by 2's on the y-axis. On the x-axis it's still going by 1's. So it looks like it's at negative 4, positive 5, and it looks like B is at 0, -4. Okay, so once again, if it helps, label your points. I jotted down A first, so I'll label that one as x1, y1. B was second, so I'll label that one as x2, y2. And now I'm going to plug everything into my equation, starting with y2. So I'm going to have -4 minus y1, x2, which is 0, minus x1, which is -4. So it looks like on the top of my ratio, we end up with -9. Down below, we have 0 minus -4. So it looks like we're going to end up with -9/4. I can't reduce that. The negative does not cancel. I know it's a negative slope because it's falling. So this is my final answer. As I said, if you wanted to use the graph to calculate the slope, we'll start with the point that's on the left because I'm reading the graph from left to right. First thing I'm going to do is see how far I'm falling. All right, so the opposite of rising. So once again, I'm going by 2, so it looks like it's dropping down by 9. Since it's falling, I'll say that's negative. And how far we're running. We're going to the right, going right 4 units. So that's going to be my +4. So it looks like my slope is -9/4, which is what I had earlier. Now for the next two examples, there's no graph. I'm just given the points directly. So you can start off, you can label them if you want. Here's my x1, y1, we'll say, and my x2, y2. So in this case, I can't really use that second method I showed you on the graph. I'm going to be forced to use the formula, which shouldn't be too bad. So I'll start off with y2 minus y1, which in this case they're the same. And then down below, I'll have x2 minus x1. Well, it looks like the first term in my ratio we're going to end up with is 0 over -13. Okay, so in this case, since I have 0 in my numerator, you could say, in the first part of my ratio, then the entire slope is going to be 0. So if I were to plot this line on the graph, it should appear to be just a horizontal line. It has a slope of 0. And I can kind of tell that that is going to be the case because both my y coordinates are the same. Okay, let's take a look at this second one. So I'll start off, I can label my points. We'll have the first one as x1, y1, the second one as x2, y2, and we'll start plugging them into my formula. So it looks like we're going to have 7 minus 5 for y2 minus y1, and x2 minus x1 is going to be -3 minus -3. So it looks like in my numerator, the first part of my ratio is going to be 2 for the rise. And then in my denominator, my run, it looks like it's going to turn to positive. So I have -3 plus 3, which is going to give me 0. So this is kind of the opposite of what we had in the previous problem. Okay, so now in this case, my slope is not going to be 0, but my slope is going to be undefined. Which means that if I were to graph this line on the graph, it's going to appear to be a vertical line. So it has no run, it only has rise. And I can see that with the 2 here and the 0 here. For example 5, now I'm asked to actually graph the line. So they give me a point to start at, so P is at 3, -2, and then they give me a slope to go along with it. So my slope is -1/6. So you can think about that either as -1/6 or 1/6. So let's think about this first case. So what that's telling me is that I am falling 1 unit, so I'm going down 1 unit, and I'm running 6 units. So I'm going 6 units to the right. Well, I'm kind of going off the graph here. It looks like that's where my next point's going to be, but I'm not really positive. So let's take a look at the other way that I wrote the slope. So now the 1 would be positive, which means you would rise 1, and the run is going to be negative, so you're going left 6 instead. So here's my next point. So now I actually do have 3 points to help me graph this line a little bit better. So it's going to look something like that. Okay, not quite horizontal, definitely has a slope, okay, but it is close to that. Which brings us to our next note about the steepness of lines. So first thing you're going to do is find the slope of each line, or you can think about it as M. Find the slope of each line, find the absolute, and I'm just going to abbreviate this, absolute value of each slope. Now, the slope with the greater absolute value is going to be steeper. So if you want to compare the steepness of 2 lines, you're going to need the slope of both of them, take the absolute value of both of those slopes, and then just compare to see which slope is greater. So for example 6, I'm trying to figure out which of these 2 lines is actually steeper. So we'll start with line 1, and you can label your points if you'd like. It's going to be hard to get my labels in here. And we'll say the first point is x1, y1, second one is x2, y2. Then we'll calculate our slope. So this is the slope for line 1. So it's going to be -2 minus -1 over 1 minus -2. Now, that double negative in the numerator and denominator is going to turn to a positive. So it looks like we're going to end up with -1 over 3. All right, now let's focus on finding the slope of line 2. So I'll use the same labels that I had up above for x1, y1 and x2, y2. So the slope of line 2 now is going to be -4 minus -3, so another double negative, over -1 minus -5. So once again, once I go to calculate my slope, both of these are going to turn to positive, and my slope is going to end up being -1 over 4. So the last thing I want to do is take the absolute value of my 2 slopes and compare them. So the absolute value for the slope of line 1 is going to be +1 over 3. So for line 1, +1 over 3. And once I take the absolute value of line 2, obviously it's going to turn into +1 over 4. So to figure out which one is steeper, whichever value is greater. Okay, 1 over 3 is greater than 1 over 4. So in that case, line 1 is steeper. Which brings us to the next part of the notes about parallel and perpendicular lines. So slopes of parallel lines. In the coordinate plane, 2 non-vertical lines are parallel, which means they do not intersect, if and only if they have the same slope. So in that case, their slopes would be equal. And for slopes of perpendicular lines, in the coordinate plane, 2 non-vertical lines are going to be perpendicular if and only if the product, so that's when I multiply, of their slopes is -1. So if I multiply their slopes together, m1 times m2, I'm going to get -1. The other piece of information I want to include here, the symbol for perpendicular is kind of like an capital upside down T. Okay, so when you see that symbol, it's telling you that the two lines pictured are perpendicular. So let's check out these examples. They give me points on line 1 and line 2, and I'm trying to determine, are these two lines parallel, perpendicular, or neither? So I'm trying to see, is there some relationship between the slopes of the two lines? So in order to calculate my slopes, let's start off, I'll label my points. Say the first point is my x1, y1, second point is my x2, y2, and now I'm going to go through and calculate my slopes. If for some reason you've forgotten what your formula is, you can just jot it off to the side, y2 minus y1 over x2 minus x1. So we'll start off with line 1. It looks like our y2, say the slope of line 1, our y2 is negative 4 minus negative 1 over x2 minus x1. Once again, we have that double negative, so it looks like I'm going to have negative 4 plus 1, which is going to give me 3, and I'm going to have 6 minus 3, which is going to give me 3. So in this case, our slope actually simplifies down to 1 over 1, or you could just say 1. All right, as long as you understand it's a ratio telling you that you are rising 1 unit and then you are running 1 unit. All right, next let's move on. We'll take a look at slope of line number 2. So our y2 is going to be 7 minus our y1, which is 5. x2 is going to be negative 4 minus our x1, which is negative 2. So looks like for my numerator, my rise is going to be 2. And in my denominator, my run turns into a positive. So negative 4 plus 2, which is going to be negative 2. Well, in this case, I end up with negative 1 over 1, or you could say negative 1. So now that I've calculated both my slopes, now it's time to compare them. So we have positive 1 over 1, negative 1 over 1. In this case, they are definitely not parallel because they are not the same. So in order for them to be perpendicular, what I said is if I multiply these two slopes together, m1 times m2, am I going to get negative 1? All right, in this case, it does work out. All right, another way to check it is to see, are your slopes opposite reciprocals? So do they have opposite signs? This one's negative, this one's positive, and are they reciprocals of each other? So if I take the reciprocal of 1 over 1, I'm still going to get 1 over 1. So for number 7, those two lines are perpendicular. And I'll use that sign or symbol for perpendicular. For the next one, problem 8, start off the same way. I can go through, label my points. We'll say the first one is x1, y1, second one is x2, y2. And then let's start plugging all our values into our equation. So I'll start off with the slope of line 1. Looks like we're going to have y2 minus y1 and x2 minus x1. Looks like I'm going to end up with negative 2 over, it's going to turn to positive, so it's going to be 8. Now I want to reduce that slope down. It's going to be negative, the whole thing, but it's going to be negative 1 to 4. Next, let's move on and take a look at the slope of line number 2. So when I plug in my values, y2 is going to be negative 3, y1 is going to be negative 4, x2 is going to be 3, x1 is going to be negative 1. So once again, some signs are going to change here. We're going to have negative 3 plus 4, which is going to give me 1. We're going to have 3 plus 1, which is going to give me 4. So obviously I can't reduce that. It's going to remain positive, so my slope is just 1 over 4. Now, clearly I can see my two slopes are not equal, so therefore they are not parallel. If I multiply my two slopes together, 1 over 4 times negative 1 over 4, I am not going to get negative 1. So they are not perpendicular. So for number 8, it looks like they are neither. There's no clear relationship between these two lines. Okay, let's take a look at number 9. So I'll start off with the slope of line 1. So we'll label our points x2, y2, x1, y1. So the slope of line 1, y2 minus y1, over x2 minus x1, looks like it's going to give me negative 2 over, these are going to turn to positive, over 8. So the last thing I'm going to do is just simplify that. Let's reduce that down to negative 1 over 4. Okay, and then let's take a look at the slope of line 2. So I know if I get negative 1 over 4, my lines will be parallel. So let's check it out. Looks like I'm going to have 0 minus negative 4 over 3 minus 2. So it looks like in my numerator, the top part of my ratio, I'm going to end up with positive 4, 0 plus 4, over 1. So it looks like my final slope is going to be 4, or we can just keep it as 4 over 1. So I know my rise is 4, my run is 1. My slopes are definitely not the same, so they are not parallel. But it looks like if I multiply these two slopes together, negative 1 over 4 times positive 4 over 1, I'm going to end up with negative 1. And I can clearly see that when I compare them, that these two are opposite reciprocals. Okay, so in other words, one is positive, one is negative, and they are reciprocals of one another, 1 over 4 and 4 over 1. So my conclusion is that line 1 and line 2 are perpendicular. Now moving on to number 10. So what they want me to do is graph a line that's parallel to line AB, and it's got to go through point P. So first thing, let's think about what do I know about line AB here? Okay, well, what I can figure out are the coordinates. So we'll start off with A at 0, 0, and B is at, looks to be negative 4, positive 2. Next thing I can get out of this line is the slope. So let's try to figure out what the slope of this line is. I actually have two options. I can either go to my graph and compare my points going from left to right, see how far they're falling or rising, and how far they are running. Now, if you don't want to use that method, I can go back and compare my actual coordinates. So I can compare my x1, y1 and my x2, y2. So let's figure out what the slope of line AB is going to be. So it looks like we're going to have 2 minus 0, y2 minus y1, and x2 minus x1. Looks like I'm going to end up with 2 over negative 4, and my final slope for line AB is going to be negative 1 over 2. Okay, and I could also see that on the graph. It looks like we went down 2 and right 4. So that would also reduce down to negative 1 over 2. So now what they're actually asking me to do is graph a line that's going through point P and is parallel to my original line AB. So if it's going to be parallel, the slope of my new line has to be negative 1 over 2. So we'll go to our graph and we'll use this slope to draw a line from point P. Okay, so from point P, I'm going to go down 1 unit and right 2, because that's what the slope is telling me to do. Now, unfortunately, that one's a little off the graph, so instead we can go up 1 unit, which is going to be positive, but then I must go left 2 units, because that would be negative. I can repeat that again for my slope, and again. We have more than enough points to graph my line. It appears like my line is going to look something like this. Passes through point P, and I know it's parallel to line AB because they have the same slope. Now, number 11 is very similar in that they still want us to graph a line, but now in this case it has to be perpendicular to line AB, and it's got to pass through point P. So I'm going to start off the same way I did the last problem. Let's just figure out where my coordinates are. So it looks like point A is at 4, 1. It looks like point B is at 6, 3. Next thing I'm going to do is try to figure out the slope of that line AB. So I'm going to use the equation. You're welcome to use the graph if you want. I can just count up and over. Well, in this case, I can at least check what I've drawn out on the graph. So I expect my slope to come out to be 1. So we end up with 3 minus 1 over 6 minus 4. So it looks like my slope is going to reduce down to positive 1 over 1. Now, for this question, what they're asking for is a slope that's perpendicular to the slope of line AB. So the slope of a line that's going to be perpendicular would be the opposite reciprocal for the slope of line AB. So this slope is obviously positive, so I'm going to expect this slope to be negative. Now if I take the reciprocal of 1 over 1, I'm still going to end up with the same thing, 1 over 1. Okay, so how do I actually graph my line? So the key is it has to go through point P, and it's going to have this slope. First thing I notice is that it's negative. So when I start off, I'm going to go down 1 unit, right 1 unit. There's my next point. Down 1 unit, right 1 unit. There's my next point. Down 1, right 1, next point. Down 1, right 1, next point. Now, the other option was to go up. Well, if I go up, that's going to be positive, but then I go left, which would make it negative. Up and left, there's my next point. I can clearly see this line is going to have a negative slope. It passes through point P, and I know it's perpendicular to line AB because when I compare their slopes, they are opposite reciprocals, or you could state that their product is negative 1. Now, number 12 is very similar to what we just did. So once again, I'm graphing a line with the given description. So it has to go through the point 0, 2, and it's going to be parallel to the line going through these 2 points. So we can graph that line as well. So I know if my line is going to be parallel to that blue line, it has to have the same slope. So let's go through and figure out what the slope of this blue line is going to be. Now I'm going to use the formula y2 minus y1 over x2 minus x1. We're always welcome to figure out what the slope is on the graph. I expect it to be positive because the line appears to be going up and to the right. So it looks like my slope is going to be negative 3 over negative 3. So my slope is going to be positive 1 over 1, or just positive 1. So I know I'm going up 1, right 1 to get to my next point. Okay, next let's focus on that red point. So I know it's going to be parallel, so I know my slope is going to be the same exact thing as the blue line. So now I need some other points to graph this line. So I can do the same thing I did with the blue line. From that red point, I'm going to go up 1, right 1, find a new point. up 1, right 1, find a new point. Or the other option is to go down 1, left 1, find a new point, down 1, left 1, find a new point. Now I have more than enough to graph my line, so it looks like this is the line that's going to be parallel to the line that passes through these 2 points. For the last problem, number 13, they want to figure out what is the missing coordinate here. So they give us 2 points, but I'm missing my one x coordinate here in this coordinate. So let's think about all the information I am given. I do know what the slope is, so I know my slope is equal to -4. Let's think about what our equation is to calculate slope. So in order to get slope, it's going to be y2 minus y1 over x2 minus x1. So let's take all the information I do have, because I do have one full coordinate here, I also have a y here, and I do know what my slope is. So let's replace everything we do know. So we'll call this first coordinate my x1, y1, the second one my x2, y2. So when I plug that into my formula, it looks like we're going to have 1 minus -3 over x minus 4. Now I know that that slope is going to end up equaling -4. So now let's see if we can simplify what we have here. So in my numerator, the first part of my ratio, it looks like I'm going to end up with 1 plus 3. So I end up with 4 over x minus 4. Now this is going to be equal to -4, or technically I could rewrite it as -4 over 1. So at this point, if I'm trying to solve for x and it's in the denominator down here, what I could do is technically cross multiply. So I would end up with 4 on one side, but on the other side I would end up with -4 times x minus 4. So it looks like in this case I can distribute that -4. I'm going to end up with 4 equals -4 plus 16. After we subtract that 16, I'm running out of space here, we end up with -12 equals -4x. And lastly, after I divide by -4, it looks like x is going to equal +3. And we can always check our answer by plugging it back into our original equation. So I'll replace x with 3. So now it looks like the first part of my ratio is going to be 4, and the bottom part is going to be -1, which does give me -4 for my slope.